files. Go ahead and fire up LP360. Right here, I'm just going to hit cancel. And the first thing that we're going to do is open up our Accuracy Star utility and enter our slant height to get our H offset. So whatever your slant height may be, just be sure to enter that, copy that, and we're going to be using that in our check shots. So when you get your H offset, we will add that to our, in this case, go back to, for this tutorial, we had our accuracy source set up just like in the diagram here. We had our tripod and base set up over our control point. And with that being said, you can see right here, check shot number 100 is actually our control. So we're going to add in 2 additional columns. We're going to have one column for the type AS, which is accuracy star, and column 6 will be the H offset. Now, if you include your control with your check shots, you'll need to make sure that every line has the same number of columns or it will not import correctly. So here you can see we've got our vegetated shots. Here is our control. And then here are our check shots. All right, we're going to go to sensor, cycle import. And we're going to import flights into new project. Next. Oops, got to make sure you choose TrueView / microdrones. Next. Folder. And we're going to go find our cycle folders. And I highlight that. Then we're going to click select folder. So everything in there is the way it should be. Yep. Click next. Now we need to import our observation file. But before we do that, we're going to need to convert our observation file into a RINEX file. And we can see right there is our RINEX file. We'll add this guy. Click next. Now we're going to set up our output location. And give this a project name. Go. All right. And then set up our reference system now. Okay, we got that done. Click next. And we can see everything is queued, ready to go. And finish. Okay, we can see everything has been imported. Usually at this point, I like to go ahead and import all of my check shots and control. That way, when we are setting up our project boundary, I can make sure that I've got everything within the coverage area. So we're going to go up to control points, import, make sure shape files is selected, add, go find our check shots, click the ellipsis, find a place to save the shape file. Next, delimited, next, select your delimiter, next, And now we need to title our columns. So column 1 is name, 2 is Y, 3 X, 4 Z, 5 is type, and 6 is our H offset. Finish. There we go. All right, perfect. All right, next thing we're going to do is we're going to go back to the sensor ribbon menu, click trajectory processing. Click next. Now we are going to enter our control point. All right, we see that trajectory processing is finished. Post process, we're going to highlight that, then click post process. All right, next thing that we're going to do is we're going to go create our flight lines. There's several ways we can do this, either auto create or manually. We click auto create. We're going to need to set up our minimum length, turn radius, and deviation. We did 150 feet minimum length, turn radius 10 feet within turn, and maximum deviation of the flight line 10 feet. We click compute. And we now have our flight lines. Now, if you're not happy with what you see, we can just go ahead and delete these guys by going up to feature edit and then using our lasso. And I'm going to hold down the left mouse button. We click the delete key on my keyboard. Yes. And then now open up our trajectory points, and we can do this manually. Go to feature edit, select edit polygon. And I want to make sure that I got all my check shots in there. Yeah, I got some that are going to be pretty close right there. So we're going to left click, left click, left click, left click. Oops. Make sure you got it selected here. All right, let's do this again. And when you're done, just double left click. I'm going to ask which layer do we want to select. And we want to select the trajectory points. And now we're going to go back to sensor, utilities. Oops, I'm sorry. Project. Where is it? It was moved. Sensor. And we'll see manual flight lines right there. And there we go. What we want to do now is turn off the trajectory points in our table of contents on the left. And we want to get rid of these guys. All we want are these parallel lines. The same thing, just use my feature edit tool. Tell it what we want to select, those flight lines. Hit delete on our keyboard. And then last, we want to go up to the feature edit. And we can see that our active layer right here is flight lines, and we want to make sure that we save that. Okay, we're going to go back to sensor. And then now we're going to hit create true view trajectory, create trajectories. Okay, you can see that our trajectory files have been generated. We're going to click OK. Now, if you are using a third-party program such as Pix4D for your ortho, at this point, you can go ahead and export your photo package right here. We can go ahead and actually we don't need to do the updating our EXIF tags because we did that when we created our trajectories. So we can go ahead and export photo package, find wherever you want to save it to. And export photo package. Now we can see here's our photo package, and it's got all of your corrections ready to go. And you would just import this as you normally would any other corrected data set into your third-party orthophoto software. Okay, now we are ready to geocode our point cloud. The first thing we're going to do is tell it what clip angle we want. And now we're going to turn off clip range, enable true track, and colorize point cloud. Click geocode LiDAR when you're ready, and yes. It's been generated. Next thing we're going to do now is run our strip adjustment. So go ahead and click the strip adjustment icon. Tell it that we want to run it on our last layer that was just generated. We're going to use the same clip angle. Really, we're not going to change anything here, but just give it a different name. And I usually just call it the adjusted point cloud. Submit strip adjustment, and yes. All right, we can see in our job manager that our strip adjustment is completed. Highlight it, and then click post process. All right, see our trajectory file has been generated. Now we can see down here in the bottom left-hand corner, it is now geocoding our point cloud. All right, we can see that we've gotten a success, so we're going to click OK. And we are ready to close our job manager. And if we look over in our table of contents, we can see our new point cloud. And our active layer, we have our adjusted point cloud as well. All right, next step we're going to run is our smoothing. However, before we do that, we can go ahead and import our border, or actually create one, and then we can run our smoothing task afterwards. Okay, to create a project border, we're going to go to Feature Edit, create feature layer, browse, and set up a location where we want to have our border. And our geometry type is going to be 3D polygon. Next thing we're going to do is click Create Feature. And left click wherever you want to start your project border. Quite be able to get him. So we can give it a shot. Up there, maybe not. Then when we're done, we'll just double click and then go up here to save edits. All right, next thing we're going to do is go back to our table of contents, click point cloud task, and then a drop down menu. We're going to select the smooth point cloud task. Click the ellipsis here. We want to make sure we have shape layer and the shape file that we just created. In this case, it is project border. Active las layer, which is going to be the adjusted point cloud. And then our source filter, we just want to make sure all points are selected. If they're not, just in the drop-down menu, select all points. If we hit the refresh, we can see nothing has been classified. Now we're going to set up an output location. Click OK. And we know we're ready to go. We've got everything in green is over here. Make sure we add that to map. Click close. And last, we want to make sure that we tile all files and we want to output all points. Click apply, point task, and execute by active layer. All right, we see a new smooth point cloud has been brought in. We're going to go over to the table of contents. Up at the very top, we can see las layer 1, and we're just going to rename that guy. And then now we're going to change our active las layer to our smooth las layer. And then now we're ready to start checking our accuracy. Okay, we're going to go to control points, accuracy estimation, settings, source points, and we want to make sure all points are selected. Again, since nothing's been classified, we can also choose create never classified. All right, our radius, we'll do 1 foot, click OK. And the first thing we want to do is tie everything into our control. So in the drop-down menu here, we're going to go find our accuracy star. There it is right there. Now click auto find. Okay. We can see that LP360 found our accuracy star. And we have very good, reliable results. And actually, we're tied in pretty close already. But to get everything tied in precisely to our control, what we're going to do is just click solve, then apply correction. All right. You just click OK. And we look over in our table of contents, we can see that we have our corrected las layer. So in the drop-down menu, we're going to select las layer 1. And then we're going to come over here and rename this guy. I'll call it corrected accuracy star. we're going to run this again. Just to confirm everything tied in the way it should to our accuracy star. Everything looks pretty good. So the next thing we're going to do is in our drop-down menu here, we're going to select full check and auto find. Okay. Look at our mean error is right around a ½ inch. Deviation is around 100. Our vertical spread is just under 600ths. We can see our minimum and maximum error, both of which are within the accuracy of the sensor, our error range. We have our RMSE, our accuracy class, and our contour interval. Now, just to confirm, this RMSE is the way that this is calculated has not been updated with the latest ASPRS accuracy standards that came out in August of 2023. So to get that, we would square our RMSE of our check shots, square the RMSE of our data set, add those together, and then get the square root of the sum. Okay, we're ready to go ahead and begin classifying our point cloud. We're going to click Point Cloud Task. And in the drop-down menu, we want to select the ground thinning. Feature geometry layer is going to be the shape layer and the name of your boundary. Units meters. We want to have active LAS layers selected, and the source points we want to have created, never classified. We want to have cell size of 1 square meter, and we want to have 8 points per square meter. Minimum, max, median, and 5 random points. Go ahead and click Apply, and by active layer. Click OK. And if we go over to our filter and select Ignore Ground, see, you got rid of quite a bit, but still a lot going on here. So what we're going to do next is we're going to go to ground classification, perform iterations. Source points is going to be created, or I'm sorry, ignored ground. Destination class is going to be ground. We want to generate seed points with a sample distance of 20 feet. Angular threshold, 2 degrees, distance 1 foot, emit edge climbing algorithm, and we want to perform 20 iterations. Go ahead and click Apply and execute by active layer. Now when we change our filter to ground, so just to get rid of these last few bits of vegetation, I'm going to click Draw Profile Line. Now I'm going to left click, use my mouse wheel. There's a point up here somewhere. There it is. We get rid of that guy. Our filter is going to be ground. Source is all points. And our destination is going, I'm sorry. Yeah, source is all points and destination will be unclassified. Next, we want to select the classify above line. And there's the point we want to get rid of. So I'm going to left click, draw a line underneath it. Double left click, and then I'm going to hit the number 1 key on my keyboard. And now that reclassified that point as unclassified. So I'm going to go through here and real quickly clean the rest of this up and we'll be ready for the next step. So the next step is we'll notice that we did miss a few spots, especially some areas that have sharp edges, such as jogging trails or trestles, things of that nature. Well, with this particular project, we had some piles of, I believe it was some dirt over here. And if we turn our points on, and then turn off our contours, oops, there we go. I can see that we've got some missing areas, and I'll really be able to see it if I draw my profile line. And we can see that we missed that. So it's really easy to fix that. We're going to use the same tool that we did to classify this. But instead, I am going to change my seed sample distance down to around 5 feet. Click apply. And instead of executing by the entire layer, I am going to execute. I can really use just about any of these, but we will try the circle here. There we go. So now when I draw my profile, I can see we're able to get that back in. And if you're not satisfied with the results, we can just make the seed sample distance even a little smaller if needed. And we can try even by envelope, and I think that should do it. Now, sometimes if you've got a really steep angle, you may need to adjust your angular threshold. So we can even try, say, 10 degrees. And maybe even go 2 feet, but you just got to be careful with this, especially if you're in vegetation. This is wide open, so I'm not too worried about it. But if we're in vegetation, you would have, and you start getting really aggressive with these angles and these distances, you could run the risk of inadvertently classifying vegetation. But again, this is fairly open, so I'm not too worried about it. Okay, now that we've got the point cloud cleaned up, there'll still be a couple spots here and there that put your mind to it. I'm sure you could find that you I'll tell you stuff you need to clean up, but if you've ever done point cloud classification, you need to know when to say when. It's because it can definitely be a time robber, no doubt about that. But we are ready to go ahead and thin this guy out one last time. So we're going to go back to our table of contents. And in the drop-down menu here, we're going to go select ground thinning again. This time we're going to select source points as our ground. There they are. And destination is going to be model key points. Wanted to do 5 points per square meter. Go ahead and click apply and execute by active layer. Change my filter to reserve model key points. Change to thin surface. And we're going to now turn on our contours on demand. And then over here in our table of contents, we're going to go to our point cloud right there. We're going to right click, go down to properties, symbology, contours. And you're going to change this to whatever contour interval that you're going to use. Then your shortest contour, I usually use 50 feet, change that to map units. And I like using the white, they're a little easier to see. Oops, okay, and apply. So now we can use these just to go through one last time and see if there's any areas that we need to clean up. We need to check our horizontal. So there's several ways that we can do this. For those of you that have the Agisoft, add-in, what we're going to do is create our, let me turn these off real quick. We're going to create an elevation model and then create from that elevation model our ortho. So we're going to go to project, export wizard, surface, and then we are going to select our model key points. And then we'll do a 1/4 of a foot cell edge length. Export format is going to be GeoTIFF. Make sure we have elevation selected and click next. Cookie cut a polygon. There's our project border. Click next, and then find a spot where we want to export it to. And then click select finish. Okay, once you have your elevation model, we're now ready to create our ortho. So from the sensor ribbon, select Agisoft ortho mapping. Retain photos. We want to generate ortho from DEM and give it a name. And if you want to go into advanced settings, you can. Really, the default settings should be fine. Now, if you have a really large project and you end up creating an ortho that is maybe a little too big to manage, which you can decrease that size, just come in here, unselect optimal ground sample distance from images, and then put in a higher ground sample distance that will lower the resolution as well as the size of the GeoTIFF. Once you're ready to submit, just go ahead and click Submit Ortho Mapping Job. Then click OK. Another good thing about this workflow is it will create your ortho in a fraction of the time. If I can find one here for this project right here with 8.5 minutes. I've already got it created. I'm going to go ahead and bring it in. So for horizontal, what we're going to do is see we've got our ortho that has been imported. We're going to bring in our check shots top. And now we're going to go to control points, accuracy estimation. And we want to go to our full check. Click auto. And for horizontal, we want to select measure mode. I'm going to start with our first check shot, which is 301. And we're just going to click the center of the target. Once we have everything completed, you can see that we've got our final accuracy right down here at the bottom. And to export your report, just go up here, export report. Give it a name, wherever you want to export it to. And that'll be that. our DEM, we are going to export this as a last layer. So we are going to go to Add Files. This time we're going to select DEM to last. And then go find our DEM right here. And click OK. Okay, so the last step is to export our final deliverables. Excuse me. So to do that, we're going to go to, for our surface, we're going to go to Project and Export Wizard. I'm sorry, we're going to go to Project and Export Land XML. You can choose, oops. Choose your classification or your filter. And then the maximum number of points and millions you want to use. And then find an export location. Once you have your surface exported, we can now go to our, change this back to our, oops, got to turn this off. Our model key points, which was right here. We can export our contours. So to do that, we're going to go to Project, Export Wizard. We're going to change our cell edge length to 1/10. Choose our source points, which is going to be model key points. There we go. Change the attribute to export to contours. Then click on the Contours tab, enter the interval that you want to use. We're going to smooth our contours, and we'll smooth them by 1/4 foot. We're going to export by polygon. So we're going to keep everything again within the polygon here. Name field will be ID. Click Next. Find an export location. Click OK and finish. All right, we see that we've got our contours finished. Again, I'm not too worried about that because in a later tutorial, we can go over how to enforce break lines for this retention pond. Okay, that has been the workflow with LP360.